طيب بسم الله الرحمن الرحيم. بداية طبعا كل عام وانتم بخير. إن شاء الله next week we'll start the new schedule. So we'll start at 8:30 p.m. إن شاء الله. So we're still talking about network access security. As we said, we're trying to secure physical device connected to a network. And we talked about the IEEE 802.1x, which is the standard that it's used for user authentication and key distribution when it comes to network access control security. So this is the layered stack. So this represents the data link layer at the device level. So the device wants to communicate with the authentication server to try to authenticate a port. This port could be a physical port in case of Ethernet, okay, which is hooked up to the wall physically, or a logical port in case of wireless. So the data link layer, as we all know, is the physical layer and the data link layer. Data link layer composed of the logical link control and the MAC sublayer. And in here, we're talking about these three standards. They represent multi-access standards. So when it comes to multi-access, as we all know, and we studied in undergrad in any networks course, you have multiple nodes, okay, connected through a shared medium. Okay, so this is the logical topology, which could be represented using like any wireless medium, or a physical layer, or physical cable, whether coaxial, whether a switch, Ethernet switch, any kind of a shared medium that facilitates these nodes trying to access this medium in a multi-access fashion. Okay, so these three standards talk about multi-access standards. This is the point-to-point protocol. When it comes to point-to-point protocol, there's no multi-access here. These are two nodes connected physically to each other using a cable, or maybe using Wi-Fi direct, or using Bluetooth, things like that. So any kind of two nodes, but there is no multi-access in that case. Okay. So this is the data link layer, and here we see two sub-layers which are related to the security protocol. We have IEEE 802.1x, and this is the sub-layer above the data link layer, which tunnels the authentication messages that is going from the device to the authentication server. It tunnels that, and 802.1x, is used only in the case of multi-access techniques. It's not being used in point-to-point as we can see here. Okay. So this is used for tunneling the authentication messages. This is called extensible authentication protocol. Extensible authentication protocol, it's not an authentication protocol per se. That's why it's called the extensible. This actually provides the transport layer, okay, through which the authentication messages are being exchanged. So in other words, the protocol stack is as follows. So you have the original. This is the authentication messages. We'll talk about it now, okay? And then you have the header, the extensible authentication protocol header, which provides like a transport layer that provides, for example, reliability, similar to TCP, provides like some kind of reliability for the authentication messages, sequence numbers, segmentation, things like that, okay? So this is the transport layer header, and then there is the tunneling through the physical layer. And this tunneling could be through the 802.1x for the case of multi-axis, or if it's PPP, then the header of PPP is directly being used. Okay? So this protocol is being used point-to-point, as we will see in a minute, point-to-point between the device and the authentication server. And this extensible authentication protocol is used end-to-end, as we will see in a minute. Type. So where is the authentication, and what is the authentication mechanism? The standards for 802.1x does not, in fact, dictate one specific authentication mechanism. Okay? It can leverage any of the authentication mechanisms that we have studied before or we will study later. So, for example, we can use the TLS. TLS is the transport layer service, which is used for authentication mechanism at the transport layer side. So we'll talk about this in a later chapter, I guess chapter 8. Okay, or the tunnel TLS. The tunnel TLS is slightly different from the TLS standard, or the pre-shared key authentication. This is similar to Kerberos. It uses the symmetric keys for authentication and key distribution. So you can think of this as a Kerberos server, which can be used for authenticating the device and distributing the keys. Or IKE version 2, which is part of IP6 standards. We'll study that in chapter 9. Or any other mechanism for authentication. Okay, so the standard for 802.1x does not dictate a specific mechanism. It just provides the interface to exchange these authentication messages between a device and the authentication server. As we said before, the authentication server is the entry point. The authentication server could actually run on the switch or the access point. Okay, and this is the entry point, whether the device is connected physically to the wall, so that activates the port to the switch, and the switch acts as the authentication server in that case. Okay, or if it's an access point, once you do the wireless discovery, and then you start to associate yourself by requesting to connect to a particular access point, you trigger the process of authentication through the 802.1x. Okay? So the switch itself might not run the TLS or the TTLS or the pre-shared key or something like this. This could run actually on another server in the backbone network, and we'll talk about this. Okay, so this is the layer stack. So here we provide the point-to-point protocol for tunneling the messages in case of multi-access, and we provide the extensible authentication protocol, which acts as a transport layer for the authentication messages. Both of them do not have a specific format for the authentication message itself. The format of the authentication message is actually the payload to these protocols, and the format of the authentication message and the number of messages is based on what mechanism or which mechanism we use for authentication. Okay. So the extensible authentication protocol provides a generic transport service, as we said. It only provides the header for transport. So, for example, it provides end-to-end reliability, because the messages, as we will see in a minute, it passes through potentially more than one node until it reaches to the final server, whether it's IKE server or a pre-shared key server or something like this. Okay? So it only acts as a transport service for exchange of authentication information between a client, which is the device, and authentication server. The basic extensible authentication protocol transport is extended by using a specific authentication protocol, which is not actually dictated by the standard. It could use actually one of the services that we highlighted. So it could be TLS, TTLS, or generalized pre-shared key, or IKE version 2, or any other authentication mechanism. All right, so in terms of terminology for the extensible authentication protocol, the device is called EAP peer. So this is the device that is trying to perform the authentication. So when you hook up the port to the wall, you trigger that process. So you become, or the device becomes the EAP peer, and it starts to exchange some authentication messages with the authentication server. And there is the EAP authenticator. The EAP authenticator is actually the switch or the access point which acts as an entry point. This particular entry point on itself may not have the authentication protocol running, okay? It only facilitates the authentication process, but it actually has to connect to another server in the backbone network to start exchanging the authentication messages. We'll see that graphically how it looks like. So you have the extensible authentication protocol authenticator, which is the switch or the access point, and you have the authentication server. This authentication server depends on whatever authentication mechanism you use. So this may be a TLS service, or a TTLS service, or a generalized pre-shared key service, or IKE service, and so on. Okay, so you have three things: the device, the authenticator, okay, and the authentication server. Okay.
Authentication server maybe Active Directory, like that, something like Active Directory.
Active Directory. لا, not necessarily. يعني هو it uses one of the common authentication services. We'll study most of them, by the way. We will study most of these. We'll study TLS in chapter 8. We'll study IKE in chapter 9. We already studied the Kerberos. So, for example, if I were to use a Kerberos service for authentication, for authenticating a device from the data link layer point of view, so I'm actually authenticating a physical node in that case. So in that case, we need to exchange messages regarding the, of course, the user ID, and then the server has to send me a puzzle that is encrypted using the password. And if I have the right password, then I can decrypt the puzzle, and then I get a ticket, remember? And then use that ticket to communicate with the ticketing server, and then the ticketing server will give me another, key for authentication, or for key distribution that I can use to communicate with the server that I'm trying to communicate, and so on. So this sequence, okay, is dictated by the Kerberos service. Another, IKE version 2, which is part of IPsec, we'll talk about this in chapter 9, may actually use different, authentication mechanism, and different types of, different format for the authentication messages, and different number of messages for that matter.
The Kerberos for service authentication, not for device authentication, right?
Yes, I can use, yes, not for device, not necessarily for device authentication, but I can use it.
Can use it?
Yes, I can use it for authenticating a device, yes.
Hook up your device, this whole process?
Right, yes.
Or you have to...
The authenticator is the one that controls that. So the authenticator is the one that dictates which type of authentication mechanism I need to use. So if that authenticator is configured to use Kerberos, then it will exchange messages through Kerberos. It may actually be configured to use TLS, may be configured to use TTLS, or something like this. So this is where the network analyst needs to configure the authentication service on this EAP authenticator. Okay. Type. What is this radius server? This radius server, as we will see in a minute, is the data link layer protocol, which is used to tunnel the messages from the authenticator to the authentication server. We talked about 802.1x, right? To tunnel the messages from the device to the authenticator, right? But then, depending on the authentication server type, the radius protocol is used to send the messages point to point in that case, from one physical device to one physical device, from the authenticator to the authentication server. We'll see how this looks like graphically now. So that's how it looks like graphically. So you have the e-peer being the device itself that is trying to activate the authentication, okay, and get the key. The outcome of the authentication process is what is basically a semi-permanent key, okay? This semi-permanent key I can use now to exchange information with any server in the network, okay? So this is the ultimate outcome of this authentication process. But in order for this to happen, the device will send some EAP messages, and the EAP messages will go from the transport layer all the way to the radius server. This radius server is the authentication server. So this server could be TLS, IKE, could be TTLS, pre-shared key, whatever. So this is a logical entity that represents any kind of authentication mechanism in the backbone network, which is configured here at the EAP authenticator. As you can see here, this EAP messages, again, this EAP messages is just the transport layer interface, and it provides end-to-end transport service, right? From the device all the way to the authentication server, all the way to the radius server, okay? So the messages, these messages go through the authenticator, okay? We call it pass-through messages. Pass-through messages, the authenticator does not process the header of the extensible authentication protocol, okay? So this extensible authentication protocol header is actually processed by the authentication server directly. But the message goes through the authenticator. We call it pass-through messages. This is similar to, for example, the routers when they receive a message, then they actually, first they decapsulate the MAC header, right? And they process only the network layer header, and then they re-encapsulate the message again to another MAC header. So the message goes through the router, okay, without changing the routing header by any means, but the MAC header will be processed, okay, through the router twice. So this is actually happening for the 802.1x. As we said, so you have the EAP header and you have the 802.1x header. The 802.1x header acts as a point-to-point data link layer protocol which tunnels these messages to the authenticator. The authenticator then will have to decapsulate the 802.1x header. It processes that header, and then it encapsulates the messages again using the radius protocol. This radius protocol will be used as a point-to-point protocol to tunnel these EAP messages from the authenticator all the way to the authentication server. This authentication server could be one of the services that we talked about. Okay? Any question here? So this is the layered model for the authentication messages. Again, all of these are interfaces. We didn't talk about the actual format of the message. We'll talk about it when we talk about the authentication mechanisms that we mentioned, whether it's TLS or IKE or pre-shared key or something like this. Okay? But the standards for 802.1x does not dictate any of these services. So the message format for the extensible authentication protocol, specifically the header is composed of the code. The code identifies the type of the message, whether it's a request or a response. Okay, and it also specifies whether it's a success or failure. If it's a success, this means that the authentication process was successful. If it's a failure, this means that the whole process failed because of some issue, whether there's an error or authentication was not done correctly due to مثلا invalid credentials or invalid MAC address or whatever. Okay. So this is the code. The identifier. So you have the code. So if we were to write the EAP message, so this is the header for extensible authentication protocol. So we have the code, okay, and then we have the identifier. The identifier here is like a sequence number for the message, which identifies the request. Why do we need to identify the request? Because when we because the request and the response, they use asynchronous communication. Okay, so you may actually send multiple request messages. So when I send you a response, I need to specify which request I'm responding to it, right? So because the communication here is totally asynchronous. So in that case, the identifier will contain will be contained in the response. So if I want to respond to, for example, request number 1, then I have to put in the identifier that this is the response for request number 1. And of course, the length, and the length in octets of the message, including the code, the identifier, the length, and all the data field. So, here is the length, okay, and there is the date. So this length actually is actually the length for the entire message, which includes everything. ماشي كده؟ Okay. So that's how it works. This is how the extensible authentication protocol works. As we said, extensible authentication protocol provides a transport service. So the way it works is that once the device is or wants to connect to a specific port, whether it's a physical port or a logical port, the first this is done to the authenticator. So if this is like an access point, then like in Windows, I right click and I say I want to connect to this network. So this request will go to the authenticator, which in that case the access point. The access point will tell you, okay, so I can admit you to the network only if you can perform the authentication process correctly. So this will trigger the authentication request to request the device to start the authentication process. So once I send the request to the device to tell the device that I can admit you only if you are authenticated, then the device will start to send the EAP messages as a request reply with the authentication server directly. As we said, the EAP messages are passed through. They are end-to-end, transport layer, right? So these messages will go in a form of request reply, request reply, request reply. This, in fact, uses asynchronous communication, so you may actually send multiple messages and the reply, similar to TCP or UDP. So the messages will go in bidirectional until at the end, either I specify that the authentication process is a success or failure, right? If it's a success, the ultimate outcome here is that the device should receive some kind of a semi-permanent key. Okay, so always the outcome of the authentication process is always a semi-permanent key, which we will see later. We can use this semi-permanent key to generate other keys for different security services, whether it's confidentiality or integrity or whatever. Okay, so we'll talk about this when we talk about the different services, whether it's TLS or something like this. Okay, so this is the transport layer service. So now we need to talk about how 802.1x works, because these messages, as we said, these are tunneled, okay, over 802.1x in the case of multi-access protocols. In the case of multi-access protocols, only if there is a multi-access protocols. In the case of point-to-point protocols, we don't actually tunnel over 802.1x, right? Yani, I guess the reason behind this is that, of course, in multi-access, you need to have better security level because, well, for multi-access shared medium, any messages go through the shared medium as one hop broadcast, okay? Whether it's a wireless or a switch or something like this. So in that case, the level of security needs to be high. And that's when 802.1x will be used to tunnel these messages for the multi-access technique. For PPP, point-to-point, you don't need 802.1x at all, okay? So, so this is the architecture. So this is the architecture for 802.1x as an access control security mechanism. So first, the supplicant, معلش يعني هم in different standards, they tweak the names a little bit. So you see e-peer, okay, which was access requester before, and now it's a supplicant. So in each standard, they keep changing the terminology slightly. So pay attention to that. So here, the supplicant, which is the device which is trying to authenticate or open a port to the network. Okay, so that's why this port is open now, because the authentication process needs to be conducted successfully before we can say that, okay, this port is now activated. So until this happens, this port is called a control port, but it's not activated. Okay. So this port, which goes from the authenticator, which is the network access point, to the authentication server, this is called uncontrolled. Why? Because this is used for authentication, right? So we cannot, so this is supposedly is actually pre-activated before we admit any kind of device to the network. So the supplicant, when it tries to authenticate itself, the objective is to try to activate this port to the server. But in order to do that, it needs to access the EAP messages directly to the authentication server. Once it performs the authentication process, so these messages will flow back and forth between the supplicant and the authentication server. The numbers and the format depends on the service that we use for authentication. Once it's done, the supplicant will have a key, okay? This semi-permanent key will be actually used to communicate with the network. Until this happens, this port is not activated. واضح كده؟ واضح كده الصورة، واضح السيكونس؟ Okay, so when it comes back to the 802.1x, or what we call the extensible authentication protocol over LANs. Over LANs, OLD. By over LAN here, we mean that this is only for multi-access protocols. Okay. So you have the EAP, which means that you have the actual authentication message, which has two headers, as we said before, the EAP header and the 802.1x, which is the EAPOL header, right? So the message will have these two headers and will be exchanged all the way with the authentication server. So this is the main message, which will flow back and forth between the device and the actual authentication server. So this will contain encapsulated e-packet, which contains the authentication message inside it, right? So this process, or this e-message, will be triggered by this message. So first, when we hook up the port in the wall, we actually trigger this message from the 802.1x level. The message will have the 802.1x header, and will have just message which has like a start request. That's it. Okay. This will trigger the authentication, the authenticator to say, okay, so you need to authenticate yourself, and we start sending these messages back and forth. So this request, in fact, comes from the device itself, or when you say associate, when you associate the device to a particular access point, right? Then the device will trigger this message from the 802.1x level. So the device will trigger this message, which will start the authentication process. So after you authenticate yourself, the port will be activated. Okay. So Once this process is finished successfully, then you get the key, the actual key. And this key is from the data link layer level. This is the ultimate objective that we're trying to seek now, right? Is that we need to have a key at the data link layer level, right? Because this is access control security, right? So if the process of authentication is successful, you get a key. The device will get a key, and this key will be used for all traffic, okay, going through this port, okay? Once you finish everything, once you finish the communication, whether you try to deactivate or deassociate yourself, okay, or your device is getting away from the access point, you're disconnecting from the wireless network or disconnecting from the wired network in any way, then you activate this message. This message will be deactivated to trigger the process of log off, which means that the device is now not connected at all. ماشي كده؟
Try again to connect and restart.
Yes, you have to start the process. Yes, absolutely.
It will not save anything.
No. This is physical. لا. This is physical. لا. This is not. This is different. When we say بقى ticket ومش عارف, لا. This is physical. The port is either connected or not connected. If it's connected, it's secure. Activated and secure. If it's disconnected, then خلاص.
It depends if the key or the SIM key.
No.
You don't store it.
You don't store. No, بالعكس. Actually, during the communication, we'll talk about this. During the communication, even if you are logged on and the port is running, you have to renew this key every now and then. So part of this process is actually will have to be done during the communication to renew this key somehow. But it's not the semi-permanent key that gets renewed. We will see that. It's not this semi-permanent key, because this key is not to be used directly for communication. No, we'll see. This key is usually used to generate a bunch of other keys. It's like the seed, okay? You will generate a bunch of other keys which will be used for communication. So these keys will have to be renewed, okay? So this is how it works. So once you hook up the port, because here we're talking about data link layer, which means physical nodes. So the device will hook up the port to the wall, or we associate with the wireless with a wireless access point. Then we start the EPOL message, okay? Then the server will say, okay, so I will send you back the extensible authentication protocol header to trigger the process of authentication, and then we do as we said before. And then at the end, either we get, if everything is successful, we get a key, or once we finish the entire communication and the port needs to be disconnected or deassociated from the wireless access point, then we trigger the message of log off. They call it log off. I don't know why they don't call it مثلا disconnect or terminate. This is how the standard calls it. Okay? Any question regarding this? So this is the end of this chapter, I think. Yeah. So this is the end of this chapter. This talks about the generic network access control security, which works either wired, wireless, anything. Okay? So in the next chapter, we will talk about wireless access security. Okay? So this is the general form of network access security. Right? So this is like the minimum requirements. We will see for wireless, in that case, we'll talk about a specific authentication mechanism, okay, which is part of Wi-Fi. We'll talk about this. But before this, we will talk first about why do we need to provide special security measures for wireless. Okay, what is the motivation that makes wireless really have this special treatment? Because it does really, right? And also, what are the terminologies that are used as part of Wi-Fi? Okay, so today, inshallah, we'll talk about why we need to treat wireless differently and what are the terminologies that are used as part of Wi-Fi, which for you is going to be like a quick refresher for some of you who did not go through this terminology before. Okay. In the third part of this chapter, we'll talk about the actual standards of wireless security, which includes WEP, WPA, and WPA2, if some of you have any idea about these protocols.
I have a question.
Okay. Right.
Before we get the key, is there like any encryption or security mechanism to protect the communication?
لا ما هو احنا اصلا ما هو true احنا we studied this as part of Kerberos, remember, right? Because when we send مثلا we send first the user ID, right? User ID is sent as plain text, right? But what we get is an encrypted message. The encrypted message is encrypted with a key, okay, which is a function of the password. And if you have the right password, you can decode that message, right? So that's a good question. So the authentication messages themselves, they need to be protected somehow. And we studied the real example for this, which is for the case of Kerberos, right? So for wireless also, we'll study about how an authentication protocol can actually work and how can we secure these wireless transmission messages, okay? Which will work differently in that case. But we need to know why in wireless case we need to use a totally different mechanism. Why especially wireless يعني ماشي? All right, so just to let you know, we'll jump from chapter 5 to chapter 7 now. Okay? Why? Because we need to stay, as I told you before, we need to stay layer by layer. Huh? We need to study layer by layer. This is not how the book is actually organized. And I tried this before, and I think this makes more sense. So you need to think within the same layer when we talk about security mechanisms. Similar to what we have done for Network 1 or for any network course, you try to study the protocols related to a particular layer, right? Because there is a special context in each layer that you need to keep in mind, okay? So when we talk about wireless also within the network access layer, right? So wireless here provides, like 802.11 or any wireless service, we talk basically about the data link layer and physical layer, right? So that's why we are jumping now from chapter 5 to chapter 7 to maintain or to stay in the same network access layer. In a later stage, once we finish this, we'll go to the network layer. So we'll study IPsec, which I think will be chapter 9, okay? And then we'll go back to chapter 6 again to talk about TLS, which is the transport layer security, okay? So just so you stay in sync with how we go through these chapters. So we'll talk about wireless network security, but was المغرب جدا صح؟ Okay. So عشان بس just to keep we'll start from a new topic. So let's just have a break, 5-10 minutes, and then we'll. Okay. So what are the factors that contributes to the higher security risk for wireless that motivates us to have to treat wireless differently? The first factor is, of course, the channel. The channel in that case, or the medium, it's not a guided medium. So when we talk about a wire, this wire, we called it in Network 1, we call it a guided medium, which means that the data and the signal itself is going through that wire. For wireless, anything that's sent over wireless is sent through one hub broadcast. So whether you want to do that or not, whether you accept it or not, whether you want to control it or not, it's actually a signal that travels through the air. So that facilitates anyone. So eavesdropping is actually guaranteed. Okay, so for wired, eavesdropping is somewhat hard, right? Because it's a guided medium. But for wireless, you cannot control it. It's traveling through the air. Anyone can, in fact, acquire the signal and If it's a plain text or he can compromise the communication somehow, he can read the information. All right? So the wireless networking is typically broadcast. So it's a shared medium. So all types of wireless communication is actually multi-access by default. Okay? So also wireless is more vulnerable to active attacks. So we talked about denial of service. When it comes to wireless, we have a special type of denial of service attack, which is what we call jamming. We didn't have that before for wired. So when we talk about wireless, you can jam a wireless node, okay? But you cannot jam a wired node, okay? A wired node, you can do denial of service attack from different levels, but from wireless, you have another attack surface, which is the jamming, which did not exist before. But actually, wireless came with the motivation of mobility and portability, right? So we know that, right? So mobility is actually a feature. It's supposed to be a feature. It's supposed to be an advantage. But this advantage also comes with some risk from a security perspective. Why? Because mobility creates some kind of dynamics that we did not have before. So for example, if I'm going through QU's network, okay, I'm moving, I'm mobile, I'm driving, and all of a sudden I came to the boundary of QU. I don't know which other wireless networks I can connect to. It may be Ooredoo network, it may be another open wireless network that I connect to you accidentally, okay? So this mobility, it's an advantage, but it also comes with a more risk in that case, okay? Also, because of the mobility and because of the portability, I don't have access to power outlets all the time, which means that the energy is limited, okay? And also, we need to make the form factor for the device smaller to facilitate the portability and the mobility and stuff like that. And that comes with also a limitation on the resources in terms of CPU and in terms of, so I cannot, so any kind of security mechanism adds some overhead, right? So for wireless, we need to optimize really the security services because we have limited resources on the energy level, on the CPU level, and everything. Accessibility. So some wireless devices, such as sensors and robots, may be left unattended. So because of the nice feature of wireless, right, we can deploy wireless nodes anywhere. Okay, deployment is very easy. For wired nodes, no, you have to hook up the wired nodes to a network or to a switch, so it has to have access to a switch, right? But wireless, I can essentially deploy thousands, okay, maybe millions of sensors to implement like a smart city solution or something like this. But this entails the fact that these sensors are deployed in the environment, okay? So what is the implication of this? They may be attacked physically. Someone may actually attack the sensor physically. It can actually, snatch or acquire the sensor physically, right? So that's another security risk. Here it's like a physical attack. So this greatly increases the vulnerability of these physical attacks, okay? Which again, we did not have this before because when we talk about wired nodes, it's kind of deterministic, it's fixed. The topology of the network is fixed, right? It's well contained within the university. We cannot just move a wired node outside the university or in the boundary of the university or something. These scenarios do not happen. But for wireless, it happens very, very frequently. The dynamicity of the wireless nodes and the wireless systems is actually very, very high. And that, as I said, it actually entails some security risks. So for example, when you talk about the wireless networking components, we have the endpoint. Here, the endpoint or the device. This device has diversity which we have never imagined before. This device essentially ranges from the level of nanorobots, you know the nanorobots, which is like microscopic devices. These are deployed in the human body to try to deliver medication or something. Okay, so there are some prototypes of these nanorobots now. Okay, and these are wireless nodes. So imagine how tiny these and what kind of limitations in terms of resources on these devices. And this can go to the, up to, having a humongous wireless node acting as a game, laptop or a game device, okay, and it uses wireless. So the diversity of the resources creates a level of versatility that we did not, we are not used to before. So as these resources scale from very, very tiny little devices to big, humongous devices, this also requires very high flexibility on the network services that we need to develop, right? So, for example, I cannot imagine running مثلا triple disk encryption for a nanorobot with the high complexity that we have mentioned before, okay? Similarly, here, so these access points also has very high versatility. So we talk about, again, a Bluetooth access point. The Bluetooth access point, this is, this is implemented in all devices. So this acts as a Bluetooth access point, okay? I can connect multiple devices to my phone, as you all know. And wireless access points. And I have base stations, big base stations, right? And I even have, like satellites. I can have drones. I can have balloons. I can have. So these access points also has scalability and has a diversity that we have not imagined before, right? So scaling this up and down creates ultimate challenges to try to design the security services for wireless, okay? Talking about the wireless medium itself, it's very, very challenging. So when we talk about wireless signal traveling in the air, you have all types of impairments to the wireless channel. Because these wireless signals have fading through the wall, they can reflect, they can diffuse, they can reflect from the wall, creating multipath fading, and maybe some of you are aware of this. We have a wireless communication course maybe next semester if you are interested to know the physics of these wireless signals and how these impairments can affect the wireless signal and the wireless cellular networks and all of this. So the impairments, these impairments on the wireless channel not only creates ultimate challenge, but also it facilitates the fact that you can jam, you can send a wireless signal just by knowing the frequency that these nodes use. If you know the frequency of the channel that this access point uses, you can send a wireless signal using the same frequency, okay, with high power. So that's jamming. So it jams any kind of wireless communication that is going on. So you can do that on the device, on the access point, you can do that easily, okay? And many people, they resort to using this jamming attack, as we have heard on satellites and on broadcast channels and stuff like that. They can conduct these types of jamming attacks. Imagine. So this actually creates some specific scenarios. These are specific scenarios that can represent different type of threats, which are distinct for the case of wireless. Most of these scenarios did not exist for the wired networks at all. So accidental association. So when it comes to accidental association here, we talk about company wireless LANs in close proximity may create some overlap transmission ranges. So you have different, you are going into the mall, or maybe you are driving in QU, okay, and getting close to the gates. You don't know what other networks are available out there, and sometimes your device connects accidentally to these wireless LANs, okay, because it's public, it's open, right? And sometimes the device connects to these transparently without you even knowing. Especially if you are, shopping in a mall and you are, moving from one network to another. Sometimes these public Wi-Fi's are open, and you can connect accidentally to these networks. So this actually creates some kind of risk on your device. ماشي? So a user intending to connect to one LAN may unintentionally lock on a wireless access point from a neighboring network. Especially nowadays, we're talking about very, very dense wireless access. So you have access points everywhere, and you have base stations and so on and so forth. Okay? So this scenario of accidental association, it happens a lot. So when it comes to malicious association, in this situation, a wireless device is configured to appear to be a legitimate access point, enabling the operator to steal passwords from legitimate access users. So this appears in the form that you want to associate yourself. So how is the wireless access actually works? First, you do like some wireless discovery. Wireless discovery is like what you do for Windows. You open this list. It gives you all the available access points, right? Sometimes you don't know, from just the name, you don't know what are the security techniques and the security levels that are implemented on these access points, right? Some of these may in fact be illegitimate nodes, okay? I can actually have an access point and act as man-in-the-middle attack. So I give you wireless access to connect to the access point, and then once I connect, I can use that to compromise your device, and from your device I can perform certain attack. Okay? So again, this happens because of the flexibility and the one-hop broadcast that's inherent in wireless communication. Ad hoc networks here, you know the difference between ad hoc networks and infrastructure wireless networks? You don't know the difference? So when we talk about wireless, there are two types or two categories of wireless networks, okay? So when we talk about Wi-Fi or cellular network, it's actually, you have one wireless access point or a base station, and you have nodes, okay? And the nodes, they have to connect to this access point or to this base station before they can do any kind of wireless communication, right? So you have some kind of centralized controller, okay? And the rule here, whenever you have a centralized controller, it's better from a security perspective. It's always better to have centralized control, right? So most of the wireless networks that we deal with on a daily basis, they call it infrastructure wireless networks. These access points, more often than not, they are connected with a backbone network, which in fact wired network, right? So whether we're talking about Ooredoo network or even Wi-Fi here, once you hit the access point, the backbone network is actually wired network, which is maintained and controlled by ITS, right? So you have wireless access only through the access point. So this is called infrastructure wireless, right? But we have also some wireless services which do not use access points. In that case, you don't have any infrastructure. You have nodes. And these nodes, they access or they can communicate with each other wirelessly with no engagement from any access point or any infrastructure. Okay? So they actually form a very ad hoc topology between them. That's why it's called ad hoc networks. Okay? So you have different, combinations of wireless communication between them. Access networks provide distributed control. When it comes to distributed control, it's very, very challenging. Okay? If the control is within one node, you can always, you can always manage and have good level of control, even on the security services. But when it comes to ad hoc, you don't have any centralized control, right? So you can easily have one of these nodes to be a malicious node, easily, right? How can we trust each other? So if we connect using ad hoc network, so if I connect to an access point, implicitly I trust this access point because I know that there is an infrastructure, big infrastructure built behind this access point, okay? So I have some higher level of trust. But if we communicate using ad hoc, why do I have to trust any node? Go ahead.
Standalone access point is infrastructure or
Standalone access point is the access points that are deployed. This is infrastructure. It's deployed. It's
usually the standalone access point is not connected to any controller.
يعني what do you mean by standalone access point?
It's configured inside the access point itself, and also if you want to change anything, you don't change by.
أيوة, where is this access point?
Usually used sometime in networks, in ministries, or.
Yes, so this is infrastructure. Yes, this is infrastructure. Yes, this is يعني هو the access point is fixed. That's what I'm trying to say. It's not mobile.
What is the
It's deployed in a fixed place.
What is the example of ad hoc?
Example of ad hoc is any kind of مثلا اللي هو if you use imagine like you have 10 nodes, okay? They are trying to communicate peer to peer or directly through each other without having an access point. So what are the protocols that facilitates this? Bluetooth, right? Because in Bluetooth you don't actually connect to a deployed access point, right? What else? Wi-Fi direct.
AirDrop or something like that.
AirDrop, yes. Yes. AirDrop, same thing. It's a peer-to-peer, point-to-point directly. You don't have to have any deployed access point. Infrastructure is like Wi-Fi, not Wi-Fi with the access points. Or 3G, 4G, 5G, 6G, anything, any G, right? So all of these are infrastructure. They require a specific device to be deployed in the environment in a fixed place. In ad hoc, we don't have this. So all the nodes are mobile, or they could be mobile. So in that case, why do we have to trust each other? ماشي? So the level of trust here is very low. Communication may happen between any of these nodes, by the way, can act as a server, as a client, as a router, right? So يعني these nodes can in fact provide service to relay messages from one node to another. So they essentially act as a router. They can act as a switch. They can act in ad hoc fashion. ماشي? These nodes are usually not owned by a certain organization. These are owned by individuals. So imagine that routers and switches are owned by individuals to provide routing services, to provide any kind of network level services. Okay? So why do I have to trust them? What is the level of trust that we can have between these nodes? So you always have, even in ad hoc networks, by the way, in many cases, you have to resort to a certain level of centralized control. يعني مثلا هنا in order for these nodes to authenticate itself to each other, ماشي? Which is what we call message authentication. ماشي? What is the type of message authentication that we have used مثلا for encrypting اللي هو message digest or the hash? Certificates مثلا. For certificates مثلا, we have to have a certificate authority. صح؟ ما هو certificate authority is somewhat like some kind of centralized entity that we both can trust. ماشي? If you provide a completely decentralized control, then it's very, very challenging to have any kind of trust. ماشي? So يعني a clear example بقى blockchain. So these nodes can have like blockchain between each other, and they can have this trust through a decentralized framework such as مثلا blockchain. And even blockchain is very, very heavy because you have to have consensus. Yeah, but anyway, يعني that's not our topic. But ad hoc networks provides really a very, very big challenge in terms of providing security because nodes inherently do not or cannot trust each other. واضح كده؟ في بقى كمان اللي هو ايه؟ non-traditional networks. Oops. Okay. In non-traditional networks, personal network Bluetooth devices, barcode readers, and handheld PDAs. These are wireless devices, which again, it's somewhat new to us. A barcode reader or PDA or something, these can read huge amount of data in just one shot. Like مثلا imagine if you have a barcode reader or a QR code reader, you can read hundreds of content or characters or text, just by doing this, right? And this content might be malicious, might actually, in fact, provide some kind of threat to the device. But nowadays, we can do that easily because we have these wireless devices. So we can read QR codes, we can read barcodes, we can do all of this. So we have access to the content, okay, with very high level of flexibility that we are not used to before. And this access to the content also imposes some threats on the device, right? Because reading this content, يعني مثلا imagine if you are going in the mall, you see a QR code, okay, you read, okay, so, there is a link, okay, let me click on this link, and off you go, okay? So you get trapped easily. So you think that the ultimate access to the content is a big advantage, but always advantages come with a cost. There's nothing يعني for free. Okay, so this is non-traditional way of access to the content. Identity theft, or what we call MAC spoofing. Again, I'm not sure how many of you went through Network 1. In Network 1, we talked about مثلا protocols, if you remember, ARP. فاكرين ال ARP اللي هو Address Resolution Protocol مثلا. Address Resolution Protocol works in the data link layer to convert IP addresses to MAC addresses, right? So we've been telling you that in the ARP, we need to discover a MAC address that corresponds to a particular IP address. So I need to connect to a server. I need to know the MAC address of that server that corresponds to the IP address. So what do? I send them a one message broadcast to everyone. Who has the MAC address of this IP address? Okay. So in Network 1, we've been telling you this, and you think from a logical perspective, it makes sense. So imagine that from a security perspective. Okay. If I tell you who has this MAC address, anyone can stand up and say, I have this MAC address, right? So now that you think from a from a security perspective, this is actually somewhat naive, right? Because anyone can say, okay, I have this IP address, and here is my MAC address. And all of a sudden, you get trapped into a man-in-the-middle attack, right? So this MAC spoofing is somewhat facilitated by the flexibility of the wireless access.
This could be also
Wired, it could happen in wired as well. But again, I mean, the flexibility and the mobility and the portability of wireless always, makes this higher risk, right? Because of the dynamicity that exists inherently in wireless communication. So this provides man-in-the-middle attacks. So man-in-the-middle attack can come in different forms, in different layers. So this is the general man-in-the-middle attacks, which is facilitated through wireless. Denial of service attack also exists in all types of communication, whether wired or wireless. But in wireless, there is a specific denial of service attack, which is a jamming. This is very distinct for wireless, did not exist before. So wireless provided attack services new attack surfaces that did not exist before. All of these are attack surfaces, right? They did not exist at all in wired networks, right? So network injection. What is this network injection بقى? So we talked about مثلا network access control. So we said that we have مثلا a node. We're trying to connect this node through an access point or a switch or something. And this will give us access to a network, right? So this, even if that port is somewhat secure and activated and everything, okay? If this node is somewhat compromised, so I have security from a data link layer perspective. But if this node, if this device is compromised somehow, it can in fact inject certain type of messages to the network, which we call it network injection. And these types of messages are actually route updates. So in network 1 or network 2, actually, we studied the dynamic routing protocol. These networks have, routers, right, inside. And these routers, in order to provide routing functions, they have to exchange route updates between each other, right? So based on these route updates, each router will form a picture about the entire network, and whenever it receives a packet, then it knows where to send this packet in the next hop and so on, right? This is routing. So if a node injects routing messages, the effect will be enormous on the network, because it can, in fact, corrupt these route updates and cause network delays or disconnections or different types of denial service attack. In that case, from the network layer perspective. So this is called network injection. ماشي? Again, this exists in wired and wireless, but because of the fact that, again, these nodes are mobile, are portable, there is very high risk that these nodes are not trusted and they come into the network. So imagine how many مثلا visitors come from different places to Qatar University every day. How many devices do they have, right? Why do we have to trust the devices or these people? What kind of trust should we have to these people? What kind of wireless access should we give them? Should we have guest access or not, right? So all of these are, again, challenges that we have to resolve when it comes to wireless in particular. We did not have to deal with these issues before because, all the wired nodes, right, are owned by, people in the university. Otherwise, I will not authenticate the port, right? So these are scenarios, specific scenarios to wireless that makes really wireless the ultimate challenge when it comes to security services. So securing by wireless transmission, when we talk about securing wireless transmission, wireless works always using the sequence of, again, wireless discovery or network discovery. So first, you need your device lists all the available wireless services out there, right? And your device sometimes connects to these networks using certain criteria, certain rules, right? So how can we guarantee the security of this process of wireless discovery? So the principal threats for wireless transmission are the eavesdropping, altering, or inserting messages and disruption. So to deal with eavesdropping, two types of countermeasures are in fact being used. One of them is what we call signal hiding techniques. Signal hiding techniques, it works مثلا for the case of wireless network discovery. So usually the SSIN, the SSIN, the service set ID. Service set ID here talks about the name of the network. So here, for example, in QU, we have مثلا QU secure, we have QU user, we have guest access, we have this and that, right? So you have these different networks of it. All of these are SSIDs, right? So if you know from the name and the name is clear, you can connect to the network that you have access to, or the appropriate one for your wireless communication or wireless application, right? But having these SSID as plain text, okay, creates more vulnerability to the network itself. Okay, so one of the ways to try to secure this process of network discovery is what we call turn off SSID. So you can configure your wireless router, in fact, to turn off these beacons that get sent, okay, regularly as broadcast. These beacons, right, they get broadcasted and everybody knows the name. For example, I can know, مثلا, the name of the wireless router for my neighbor or my neighbors, right? Because I can see it's a plain text. So I know that this wireless router is in the house of my neighbor XYZ. I know that, right? So if we want to have like some security level when it comes to this process of network discovery, I can turn off the SSID. So if I turn it off, what is the way to connect to it or associate to it?
Add it.
Hmm?
You have to add it.
You have to manually enter it. So in Windows, for example, you get the list, but you also have the flexibility of typing the name of the SSID because it does not appear here. So if you know the SSID, you can type it and then you can connect to it if it exists. So that provides some level. Of course, it's not enough, but yani, these are different levels of security.
I usually name my wireless hidden network.
مثلا حاجة كده يعني. Because many people, they are used to naming their SSID with sometimes they put the house number and it's like we're giving information to the people for free. And assign cryptic names to the SSID. So somehow I don't enter the name in that case. I need to enter the key that I use to decrypt the SSID. This is usually not very common type of securing the SSID. Reduce the signal strength. That's interesting. We cannot do that manually in our home wireless routers, at least, but we can do that in certain types of base stations and access points. How do we reduce the signal strength? By controlling the power. By doing this, what do we do, essentially? The wireless beacons that broadcast the SSID, they have small perimeter, right? So this means we limit the access to the network for only a small area, a small geographical area. So this is a spatial mechanism for controlling the security, if you will. Okay, a spatial mechanism. It's based on the space or the range of the signal. Locate the wireless access points in the perimeter of the building away from the window. And what that means is, again, these access points sometimes, if they are close to the perimeter or the boundary of the network, ماشي? Let's say, مثلا, you have an access point close to the exit of QU, right? So this actually provides wireless access at the boundary of the university, right? So this creates extra threat. Why? Because this will allow people from outside to actually connect, right? So this increases the risk, right? But if you contain these access points in closed areas, away from the windows and stuff like that, this will reduce the possibility of external people connecting to it. Okay? Again, this is another special mechanism to control the security of these wireless access points. طبعا encryption and authentication are effective against the eavesdropping and active attacks, as we said. A denial of service attack can also be countered through site surveys. And what that means, site surveys sometimes are used to measure the power of the signal in different frequencies. I can do that. What is the purpose of this? Is like, if you want to have good wireless communication, you should select this, the frequency that has the lowest type of interference, right?
SNR?
Using LSNR, signal to noise ratio, or measure the power of the wireless signal in certain frequency. Basically, you have a receiver that you adjust it to a specific frequency, and then you measure the power of the signal at this frequency. So you can do that in different frequencies, right? And then you select the frequency that has the lowest activities of wireless communication. So what is the purpose of this? if you have your communication within this frequency, you will have less interference, right? So that controls not by the jamming, this controls the interference a little bit, okay? So by having these measurements, it allows you to select the clear interference that has the lowest activities of wireless communication. Okay, questions so far? Securing by these access points, in addition to what we have talked about in terms of the network discovery and association, we have, of course, again, the 802.1x. So 802.1x also provides the foundation to also provide some kind of security through authentication and key distribution for for the wireless nodes بقى نفسهم, okay? The standard here provides an authentication mechanism for devices wishing to. Here we'll talk about the specific authentication mechanism for the case of Wi-Fi, at least for Wi-Fi standards at least. We'll talk about a specific authentication protocols, including WEP, WPA, and WPA2. We'll talk about the details of these and how we can obtain this semi-permanent key. How can we generate all the session keys, temporary keys out of these semi-permanent key. ماشي؟ طيب. Securing wireless networks. This list is actually how to, again, it's redundant with the previous one, but this exists in a different standard document. Again, we have multiple standard bodies. We talk about NIST, we talk about ITU, IETF, and so on. So each of these entities, sometimes in their standard documents, they provide some information about how to secure wireless transmission, which will have some overlap and some redundancy, but there is also slight differences between them. So here, this is regarding the ITU standard. They talk about the use of encryption, of course, which is straightforward, but also the use of antivirus, anti-spyware, software, and firewall. We'll talk about firewall in chapter 10, which provides system-level security. As we said, turn off identifier for broadcasting. Change the identifier on your router from the default one. Some people, as we said, your wireless router sometimes comes with a default configuration, default SSIN, right? So some people, they don't even know how to change it, so they keep it as the default. And that creates a significant amount of interference, and it subjects your wireless router from accidental association by different people. So it's very advisable that you have to go through the wireless configuration of the router and change everything. Okay? This is even more severe. You bring the router, you start using it, and then the router has admin as a preset password for. So if you leave it as admin, right? So this actually allows anyone to connect your wireless router and configure everything and hijack your router even by setting the password and controlling all the wireless configuration on your wireless router. You can actually have a filter in certain types of access points and router. You can even filter the access for this wireless connection based on the MAC address even. Okay. Turn off? The DHCP. Yes, you can filter based on IP address, you can filter based on MAC address, you can filter based on both, right? So you can have whatever rules. Usually the home routers, not all of them, they allow you to do that, but in certain types of wireless routers and wireless access points, they can allow you to filter nodes based on IP address, filter nodes based on MAC address, and so on. Okay? So only these nodes will have access to the wireless access points. So mobile devices have become an essential element. Here we'll talk about the mobility and what kind of threats that can be caused by the mobility. So here, prior to the widespread use of smartphones and network security was based upon clearly defined perimeters. So when we talk about wired nodes, the perimeter or the boundaries of these wired nodes is deterministic, and more often than not is fixed, right? Because these are hooked up with certain wires, right? So you can know exactly the perimeters and the boundaries of these devices, When it comes to wireless بقى, the perimeter is actually fuzzy. Okay, it depends on the wireless ranges, it depends on the mobility of the nodes. So the perimeter of the network is actually fuzzy. And that creates multiple scenarios like accidental association, like people coming from outside connecting to your network, and all of these creates significant threats to the wireless communication. So due to the massive changes, an organization's networks must now accommodate growing use of new devices. So you can buy this next day. QU needs to accommodate this extra device. So every day there are new devices that come into the network. And what level of access should we give to these new devices? We need to actually configure that.
Scalability.
For scalability for wireless is really huge. So you have to tailor, you have to accommodate different versatility for these devices. Many devices come in every day. Cloud-based applications are becoming very widespread. So I can have Dropbox service access it on my device. And these actually provide another level of threat, right? Because accessing Dropbox from these wireless devices may in fact provide threat to my enterprise network, right? So through my device I can access any kind of cloud-based service, and I can read some content or deal with some content or maybe store some private information on Dropbox, and people may have access to it. And the extreme example of this is that you can have all your passwords stored in one file and then you put it on Dropbox. So you can imagine that. So you can have access to these files, and you can create a huge amount of damage.
How is this related to wireless?
Now again, it's because of the versatility of services of wireless. طبعا it exists in wired as well, right? It exists in wireless as well, in wired as well. But the flexibility and the portability of the wireless creates these dynamicity much more challenging. ماشي, more than wired.
I mean the physics of wireless is not related to
لا, not due to physics, due to the portability and the mobility. ماشي, and the fact that you can own new wireless devices every day. Now I have my watch, right? I have my laptop, I have my iPad, I have my cell phone. I have very easily new devices every day. ماشي? So you have the concept of deep perimeterization. Deep perimeterization talks about the fact that the perimeter becomes really fuzzy. The perimeter of the network becomes really fuzzy. Because many devices from outside, they can access the network every day. And also the devices in the network, they can go outside. Imagine, مثلا بلاش, not devices connecting to the enterprise network. Imagine I take my device laptop and I travel outside, right? I travel even to the US. I have my laptop. Okay, so now I can connect to the hotel's network, the hotel's Wi-Fi, right? This hotel's Wi-Fi is actually somewhat a public network, right? It can have its own security level, which may or may not be enough, right? By connecting to this wireless network, now my device is part of a somewhat untrusted network, okay? So if this untrusted network provides some kind of vulnerability to my device now becomes a threat to my enterprise network. ماشي? So this scenario, مثلا, it happens a lot. So you're supposed to have the awareness that when you travel outside, you need to connect to trusted networks, but who does that? Once you reach to the hotel, you open your laptop, you connect to the network, you don't actually do any security checks, and that might actually create some threat and some risks which you do not actually estimate. The external business requirements, these are, again, external services that you connect to or you deal with, and that also might create some threats to your enterprise network. The central element in all of these changes is the mobile computing, is the mobility. The mobility of the computation and the communication that have been facilitated using this wireless device. So the same, more or less, again, this is again redundant, the same threats that we talked about more or less, these are mentioned in another NIST document. So this is provided in the NIST document. So here we talk about lack of physical security controls. So here the security policy for mobile devices must be based on the assumption that that any device may be stolen or at least accessed by malicious parties. So if you have any, again, this talks also refers to the physical attacks. So if you have your wireless device unattended or something, somebody might have access to it physically, and they can use it to provide like some attacks to the network. Use of untrusted mobile devices. The organization must assume that not all devices are trustworthy. So devices come every day. Which devices should we trust, and which level of access should we give to the new devices? How can I know that this device is owned by an employee or is owned by a guest? And what kind of access should I give to each one of them? Use of untrusted network. This is the scenario that we just talked about. So not only the users are untrusted, the networks that they use, it may be untrusted. So if I go outside and I connect on a wireless network of a hotel or something like this, then from there I have access to my enterprise network. So these are untrusted networks that we need to have different security treatment for. Use of untrusted content. This is the scenario that we talked about. So we can read QR codes, barcodes, things like that in one shot. Okay. Use of applications created by unknown parties. It's easy to find and install third-party applications on mobile devices through app stores or something like this. So which of these app stores should we trust? Okay, so you can set up any kind of applications on your mobile device through different app stores, GitHub and these kind of things. So these services, they have developed certain level of trust throughout the time. But in the beginning, people usually they shy away from trusting these services. So you have to stay in the picture for a long time before people can start to trust you. Interaction with other systems. Unless an organization has control of all devices involved in the synchronization. So this talks about Dropbox, for example. So you have synchronization, right? So your device, once it gets the access to Dropbox, it synchronizes the content. So content from your device goes to Dropbox. So this content, it goes to Dropbox. This content might be private, and now it's getting away, it's getting outside the network to a third party that you don't necessarily trust, right? Use of location services. This is a scenario that we talked about. If we are مثلا shopping in a mall or something and we're walking, and some location-based services, like based on your location, you may get actually some ads, right? So you receive some ads. Oh, there is a discount in this shop. Please click on this link to start shopping. When you click on this link, that's it, right? So there are also location-based services that provide different types of threats through wireless. So this is the mobile device elements. As we said, we have to provide different types of security mechanisms in each of these components. So for example, this is the wireless device that we need to protect it from physical attacks and so on. We need to maintain antivirus. We need to maintain like some security levels on it. We need to use tunneling when it comes to secure ports when it comes to accessing the network through physical nodes, and also the network level to protect it from any kind of network injection and so on. So this talks about VPN tunnel or SSL, and we have different levels, different types of services at each layer. We'll talk about it. And why do we need to have security at each and every level, right? If you have security in one layer, right, that doesn't protect you in another layer, essentially, right? So you have to provide the security in each of these layers. So we'll talk about why we need to provide that. Firewalls, for example, provide system-level security, which might actually span all the layers. It might actually combine some of these layers. So we can have rules based on IPs, MAC address, okay, and service. So we can block, for example, HTTP on block 80 for certain types of IP addresses and so on and so forth. So this provides system-level security for the entire system, right?
So here, when we are talking about security, it's the same for LAN?
Yes.
For wire? Or there are another functionalities?
ما هو بقى, as we said, here we assume that 802.1x, as we will see, is being used. Here we're talking about network access control, right? So 802.1x is the minimum requirements, right? But for wireless, we need extra things. That's what we need to talk about. For wireless, we need extra things due to what we have talked about so far. The motivation behind بقى اللي هو فكرة network discovery, association, with the association, the dynamicity of this wireless, all of these requires the fact that you need to have extra things on top of اللي هو extensible authentication protocols and 802.1x. Okay, you need to have other things on top of that.
This is only for the data link layer, or you're talking about all layers?
No, this is wireless talks about network access layer. When we talk about wireless, we refer to network access layer, right? Because network and stuff, this is, as we will see in a minute, when we talk about wireless, we talk about a particular medium. ماشي؟ خلاص يبقى بنتكلم على network access. معناها data link layer and physical layer. Network layer, is it medium specific? Network layer is medium agnostic. It doesn't care whether you are wireless or wired. So once we start to talk about network layer, we'll stop mentioning the medium because we don't care. واضح? We will not talk about medium. Once we say wireless, we refer to a medium, so implicitly we refer to network access control. ماشي? So we need to secure a port. ماشي? So, okay, so this is the end of the first part of this chapter, which is basically, now hopefully all of you are motivated that wireless is indeed provides the ultimate challenge when it comes to security. So hopefully we are now convinced with that. In the second part, this is a quick refresher. Wireless terminologies, which prepares you for the third part. For the third part, we'll start to talk about the security services for 802.11 اللي هو ده protocol, this particular protocol, ماشي, which is specifically called 802.11i. ماشي. So IEEE has the group or the committee which is 802. 802 is a consortium of يعني committee كده which standardizes all types of network access standards. Not only wireless. يعني wireless here we're talking about 802.11 مثلا. 802.11 is actually a family of standards, right? But also 802.3, which is, هتفكر? 802.3 refers to Ethernet.
Yes.
ماشي? So we'll not talk about 802.3 here خالص. 802.3 is Ether. 802.2 provides the standard for اللي هي sub layer اللي هي called logical link control. ماشي? So 802.11 refers to wireless, which refers to a particular medium. ماشي? So in 90s بقى, IEEE 802 committee formed a new working group to work on 802.11. Before that, طبعا 802.3 was standardized, was being used and stuff like that. 802.11 ماشي, was the first version of it was 802.11b. 802.11b talks about wireless communication in 2.4 gigahertz. ماشي? So this was the first one. حتى the data rates were not that high, like 11 megabits per second or something. This was the beginning of it. ماشي? They developed the protocol and the transmission and the specification. Since that time, the demand for wireless LANs at different frequencies and data rates has exploded. they would have never imagined the wide adoption of what they could not imagine. Once they have standardized 802.11b, يعني the number of startups and vendors who try to implement these standards and make it widely available in wireless devices, it was beyond imagination. Hatta they started to talk about how can we certify these products. These products are really built in an uncontrollable way. So we need to have a consortium to start to certify these products. We need to make sure that they comply with the standard because it's enormous, right? So there was an explosion of adoption for this. Yani people were really hungry to adopt wireless services. They have experienced the flexibility, the portability, the mobility of wireless services, and they enjoyed that a lot. So they started to buy these wireless devices, and that actually exploded the market of wireless services beyond imagination. So some terminology for 802.11 here. طبعا we know the access point. The access point here is the entity that provides the functionality for wireless access, and it has it provides بقى اللي هي some services like association and distribution. We'll talk about each one of them. You have the concept of basic service set. A basic service set is actually an access point and a group of nodes. Together we call it a basic service set. So we'll see that in the graph in a minute. A basic service set is composed of one access point and multiple nodes. And this provides the minimum level of multi-access, right, between these nodes and the access point. So if I'm next to Muhammad here and I want to communicate with him within the basic service set, my communication has to go through the access point first before it goes to Muhammad. لازم. Okay? There's no ad hoc communication. The coordination function is a logical function, which very commonly it runs on the access point. It's actually a process or a service that provides the coordination for the communication between these nodes. And usually this runs on the access point. There is the concept of distribution. So if me and Muhammad, we are part of the same basic service set, okay? So we can communicate through one access point, okay? But if you are connected to different access points, which means we are not part of the same basic service set, right? So in that case, my communication first goes to my access point. From the access point, it goes to the backbone network, and then it goes to the access point, then it goes to Muhammad. We call this distribution. ماشي? It has to go first through the backbone network. We'll see that in the graph. It will become very, very clear. So, which means that essentially in a network like UU here, طبعا, as you can imagine, we have tons of these access points, and we have a distribution system which is the backbone infrastructure, which currently is maintained and controlled by ITS, right? So the multiple access points, each one is a basic service set. The group of multiple basic service sets, we call it a extended service set. ماشي? So the extended service set here refer to all the basic service sets within a particular network, like UU. ماشي? All the access points, they form within each other, or they form the name of a extended service set. ماشي? Which means that to communicate through the extended service set, generally we use distribution through the backbone network. طيب, we have the MAC protocol data unit. The MAC protocol data unit here refers to the MAC header and the service message. This service message is what we call service data unit. يعني يعملها كده بالظبط. We have the MAC header, and we have the service data unit. Okay, so from wireless perspective, this is the protocol data unit. It's composed of the MAC header and the service data unit. So all of this is called the MAC protocol data unit. This is called the service data unit. واضحة دي؟ طيب, this is how it looks like graphically. So this is the distribution system. This is one basic service set. This is one basic service set. If I have this whole thing, it's called a extended service set, probably. So this is the extended service set. Okay, so QU has a big extended service set, which is composed of multiple basic service set. Together they are connected through the distribution system. This distribution system, more often than not, is actually a wired network. So here there are multiple switches and routers. Okay, it's not necessarily wireless. ماشي؟ واضح كده؟ طيب صار بقى طيب فالواي فاي الاينس هنا الواي فاي الاينس في الاول كان اسمه ايه؟ وايرلس ايثرنت كومباتيبيليتي الاينس. After the 90s they started to form a group of wireless Ethernet compatibility alliance. They called it compatibility alliance because they have been very concerned about the compatibility with the standards. So they started to form this group to check the compliance of all the products with the standards of ال 802.11 بالتحديد. ماشي؟ So later on, subsequently, it's renamed to the Wi-Fi. يعني هو Wi-Fi, before it was called Weka, right? And after that, they named it Wi-Fi. ماشي? So the Wi-Fi Alliance, they started to form all types of standards. لما 802.11 and B بقى, there's B, there's G, there's A, there's P, there's AC, there's I, and the list goes on. Okay? So the first one was 802.11b, as I said, 11 megahertz, 2.4 gigahertz, within the 2.4 gigahertz range. And after this, they formed the 802.11g. 802.11g jumped from 11 megabits per second to around 50 or 54 megabits per second, something like that. Right? So there was a big upgrade in terms of the data rates, but still within the 2.4 gigahertz. And then they started to form the Wi-Fi 5. Wi-Fi 5 here refers to communication within the 5 gigahertz. ماشي؟ اللي هو ال 802.11a. 802.11a provides communication within the 5 gigahertz. In our home network, for example, we have both. We have 2.4 and we have and 2.4 actually they use even AC or P depending on your wireless router at home. And in 5 gigahertz, most probably they use 802.11a, right? So recently, Wi-Fi has developed, Wi-Fi Alliance developed the certification procedures. This was very key because the explosion of products made them really concerned about the compatibility. And compatibility is very important because it facilitates the communication through multi-vendor devices, right? So that's a big issue. So here, this is the stack. So here we talk about the general 802, the 802 standards. All the 802 standards, they are referred to here, okay, which includes مثلا 802.3. 802.3 اللي هو for Ethernet, right? So this column here talks about the specifics of 802.11, which refers to the wireless mechanism, right? So if we talk about, طبعا احنا قلنا network access control is composed of the data link layer and physical layer. And the data link layer is, again, you need to refresh your mind with network one. Huh? So the data link layer is composed of 2 sub-layers, اللي هم logical link control and the MAC layer. ماشي? If you remember, here for logical link control, it provides flow control and error control, especially people who are who actually went through a network 2. They studied this in more details. MAC layer, of course, provide the multi-access. This is the most important functionality of the MAC layer. Also addressing and error detection and so on. Physical layer provides the encoding, the decoding, and so on. طبعا when it comes to wireless, we need to have extra functionality to account for all the scenarios that we've talked about. Not only from a communication perspective, let alone security later on. So first of all, There's nothing here that corresponds to logical link control. Why is that? If you remember in network one, we've been telling you that the main idea behind the separation of these two sublayers, right, is to make the logical link control medium agnostic. If you go back to network one, so we've been telling you that logical link control is designed to be medium agnostic, and that's why in the standards there is a special standards for logical link control here called 802.2. ماشي? They standardize this separately, and then MAC and physical layer, they have combined this in 802.3 or 802.11. Okay? So when it comes to 802.11, you will see some specifics within the MAC and physical layer. Logical link control is separate because logical link control is medium agnostic. Even if you're talking about fiber optics, logical link control doesn't change. Whether it's wireless, wired, fiber optics, it doesn't care, right? So for MAC layer, when it comes to medium access control and multi-access techniques in particular, for wireless, we have to provide some kind of reliable data delivery, wireless access control protocols. If you remember, why do we need to have these techniques for wireless? For wired, for multi-access techniques, we studied مثلا in network 1 اللي هي multi-access techniques اللي هو ال carrier sense multiple access with collision detection, right? And then in wireless, we told you that we cannot use detection, of course, because in wireless you cannot detect the collision. صح? And that's why we have to do a collision avoidance, right? So collision avoidance is a totally different mechanism, and that's why the multi-access for wireless has to have its own specifics, right? Because of this notion that we cannot detect collision, right? So we need to avoid collision but not detect it, right? So this provides some differentiation when it comes to the MAC layer and multi-access techniques. When it comes to physical layer بقى كمان, maybe some of you, especially computer engineering students, they studied in network tool physical layer for wireless, and we studied the difference between broadband communication and baseband communication. So for wireless here, we have to talk about RF بقى, اللي هو radio frequency, and we have to do modulation, demodulation. Maybe some of you studied that in any DSP or signaling course. We have to do modulation, demodulation, things like that. In wired, we talk about baseband communication, so we don't have to do modulation. Why do we need to do modulation for wireless? Because we have to communicate within a specific frequency, right? So the signal itself is in the baseband, but in order to communicate it wirelessly, because it's in the air, we have to shift the signal in a specific frequency before we can transmit it, right? Otherwise, if we communicate all the signals within the same range of frequency, the interference will be huge, right? So we have to use what we call broadband communication. Or in other words, we have to use modulation and demodulation. So that's specific to wireless. We did not have to do that for wired. For wired, we use baseband. Why? Because it's guided, right? We don't have to worry about interference. There is no interference. واضح كده؟ So this is the MAC layer PDU or protocol data unit, which is composed of the MAC header and the trailer. And here the trailer uses what we call cyclic redundancy codes, and this is the service data unit. So this is not new. So this is the last slide, hopefully. So these are the services that are provided as part of the Wi-Fi standards. As we can see here, there are some functions here which are specifically related to security, like what? Like authentication, de-authentication, and there's privacy here, right? So these are related to security. Others are functions related to wireless transmission, but not related to security. So when it comes to, so here, as you can see here, for this security stuff, we see LAN access and security, right? So these are security functions which are built within the Wi-Fi standards. You have the concept of association. Association here talks about associating yourself to a particular access point. This association is provided through the distribution system. Why? Because you may have access to multiple access points, right? So in order to control the association to a particular access point, this is controlled within the distribution system. So I have to have control to which access point you need to connect, right? There is that disassociation here is when you leave مثلا the network of QU, you need to deassociate yourself from any access point within QU, and so on. This is the concept of distribution which we talked about. So any kind of communication that goes from one basic service set to another basic service set, it has to go through distribution. This is about the concept of integration. There's a slight difference between distribution and integration. So we know that this is a basic service set, and there is another basic service set, right? And this is the distribution system, right? So if I do communication from here to here, this is a distribution, right? But there is a node here that wants to connect to the internet, which means it needs to connect from the extended service set within QU to outside, to maybe بقى Orido network and internet, right? So this is called integration, right? So integration is when you communicate from the extended service set to another external network. This is called integration. There's the concept of reassociation. Reassociation here happens when you move. يعني you have مثلا a car, okay, and you are moving. So in that case, you perform association, and at some point, you may actually perform reassociation to another access point due to the mobility. We call this handoff. So you hand off from one basic service set to another basic service set. So this requires reassociation. واضح كده? So these are the basic functions that are defined in the Wi-Fi standards, in all the Wi-Fi standards, ماشي? In all the 8.11 stuff. Unfortunately, this is the last slide. This is not new. This talks about the difference between integration and distribution. That's the only information here. So integration enables the transfer of data between the 802.11 LAN and station on integrated IEEE 802.x. Could be it could be 2, 3, any kind of extended or external network. It takes care of any address translation. So if I'm moving from QU's network to another network, so maybe here I use IP address, maybe in Orido network I use different types of addresses. It translates, this integration is a major engagement, and usually it requires على فكرة service disruption. Try it مثلا have مثلا a call and you drive your car ماشي, and you مثلا you have WhatsApp call ولا حاجة, and you go through the QU's network. Usually you can maintain the call. Once you go outside the gate, you hand off from QU's network to Orido network, right? Here بقى more often than not you will have service disruption. Why? Because unless there is a very big service level agreement between QU and Orido, usually this requires complete translation and complete bridging from this network to this network, and that usually disconnects the communication. In some cases it takes minutes أصلا or it takes 1 minute مثلا to switch completely from this network to this network. Distribution is not as costly, it's not as expensive, because you are still within the same enterprise network, but you are moving from one basic service set to another. It goes through the distribution network, and that usually requires no service disruption. Okay? So we'll talk about this we'll talk about this next time, inshallah. Okay.